Picture a civilization so advanced, so meticulously planned, that its cities boasted underground drainage systems, standardized bricks, and grid layouts rivaling modern urban design, all more than 4,000 years ago. This wasn't Rome, Athens, or even ancient Egypt. This was the Indus Valley, a sprawling network of cities along the banks of the Indus River, where people thrived with a sophistication that still baffles archaeologists today. But here's the twist: despite their remarkable achievements, we've only scratched the surface of what they truly accomplished, because somewhere along the way, their most groundbreaking technologies vanished, lost to the sands of time, leaving behind only whispers of their brilliance. What if I told you that the people of the Indus Valley might have harnessed inventions so ahead of their time, they could rewrite history as we know it? Think about it, a society that mastered urban plumbing while the rest of the world was still figuring out basic agriculture. A culture that traded across continents without leaving behind a single decipherable script. And yet, when their cities were abandoned, their secrets went with them. Today, we're left piecing together fragments, artifacts that hint at mind-bending possibilities, from advanced metallurgy to energy systems we can't fully explain. How could a civilization this ingenious simply disappear without passing down their knowledge? That's exactly what we're diving into today. We're uncovering 25 of the most astonishing lost technologies of the ancient Indus Valley, innovations so extraordinary, they'll make you question everything you thought you knew about the past. From mysterious devices that might have harnessed natural forces to construction techniques that defy explanation, each one of these discoveries opens a door to a world far more complex than we ever imagined. So buckle up, because this isn't just a history lesson. It's a journey into the unknown, a chance to stand face to face with the ghosts of ingenuity, and maybe, just maybe, catch a glimpse of what they left behind. Ready to explore? Let's begin. Imagine walking through the streets of Mohenjo-daro 5,000 years ago. Beneath your feet, an intricate network of brick-lined drains snakes through the city, channeling wastewater away from homes and public spaces with precision that wouldn't become common elsewhere for millennia. This wasn't just a crude ditch, it was a meticulously engineered system, complete with sloping floors to guide flow, manholes for maintenance, and even covered channels to prevent debris from clogging the works. Every house connected to this underground grid, each with its own private bathing area and waste disposal chute, all feeding into the main arteries of the city. The scale of this planning is staggering. While the Egyptians were still perfecting pyramids and Mesopotamia relied on open canals, the Indus Valley had already cracked the code on urban sanitation. But here's what truly sets their plumbing apart. It wasn't just functional, it was standardized. Every brick in those drains matched a uniform ratio. Every pipe followed the same engineering principles across cities hundreds of miles apart. This level of coordination suggests something radical for its time. A central authority with advanced knowledge of hydraulic engineering, enforcing codes that modern builders would recognize. Archaeologists have found evidence of sedimentation tanks to filter water before it entered the system, and some drains even incorporated curved joints to reduce blockages, a technique we associate with much later Roman innovations. How did they develop such expertise without the mathematical treatises or blueprints left behind by other ancient cultures? Perhaps most puzzling is the abrupt disappearance of this technology. When the Indus Valley cities declined, their plumbing knowledge seemingly vanished with them. Later civilizations in the region, like the Vedic peoples, built nothing comparable for over 1,000 years. It's as if this entire branch of engineering was erased from history until the Industrial Age. Even today, parts of the system remain functional after millennia buried underground, a silent testament to builders who understood materials and hydraulics in ways we're still unraveling. What other secrets might those buried bricks hold? The answers could rewrite our understanding of ancient innovation. Now let's talk about something so simple yet so revolutionary, it still leaves engineers in awe: the bricks. Walk through any ruin of the Indus Valley, from Mohenjo-daro to Harappa, and you'll notice something uncanny. Every brick, whether used in a house, a well, or a city wall, fits the same exact ratio: 4:2:1. Not roughly, not approximately, precisely. This wasn't just a happy accident. This was a calculated, empire-wide standard that allowed builders to work with a consistency unmatched until the Industrial Revolution. Think about what this meant. A brick molded in Harappa could seamlessly fit into a structure 500 miles away in Lothal without modification. Construction wasn't just fast, it was modular. Walls rose like puzzles snapping together, drainage channels lined up perfectly, and repairs could be made with replacement parts pulled from any stockpile. No guesswork, no custom cutting. This wasn't just convenience, it was a logistical masterstroke. Today, we take standardized parts for granted, from screws to shipping containers. But 4,000 years ago, this was nothing short of genius, and here's where it gets even more intriguing. That uniformity hints at something far bigger than clever engineering. It suggests a central authority with enough control to enforce strict production rules across an area larger than ancient Egypt and Mesopotamia combined. Picture a governing body that could dictate not just brick sizes, but kiln temperatures, clay mixtures, and quality checks across a 1,000-mile civilization. No scribbles on clay tablets debate the right brick dimensions, no regional variations, just flawless, silent obedience to a standard that endured for centuries. But how? No blueprints survive, no royal decrees etched in stone, just the bricks themselves whispering of a system so efficient it bypassed the need for written instructions. Some researchers argue this points to an early form of mass production, state-run kilns pumping out identical units by the millions. Others believe it reflects a shared technological culture where knowledge was so ingrained it didn't need documenting. Either way, when the Indus cities fell, this precision vanished. Later cultures in the same land, like the Vedic or Mauryan empires, built with irregular, hand-shaped bricks for over a millennium. That perfect ratio lost. Perhaps most haunting is the question of why such a practical innovation wasn't copied. Rome's concrete inspired centuries of imitators. The wheel spread across continents, but the Indus brick standard died with its cities. Was the knowledge too tightly held? Did the collapse disrupt trade networks that distributed these materials? Or was there something about their society, their governance, their values, that made this system impossible to replicate? Every perfect brick left behind is a clue waiting to be pieced together. Rising from the heart of Mohenjo-daro stands a structure that defies expectations: the Great Bath. This isn't just a pool, it's a 40-foot-long, 23-foot-wide masterpiece of hydraulic engineering, lined with bricks so tightly fitted, not a drop of water could seep through. The precision is staggering. A layer of natural tar coated the floor and walls, creating a waterproof seal that held strong for millennia. But here's what's truly remarkable: this wasn't slapped together. The bath was built atop an intricate network of corridors and channels, with a sophisticated drainage system that allowed water to be emptied, cleaned, and refilled at will, an innovation unmatched in the ancient world until the Roman baths 2,000 years later. What was this space used for? Theories abound. Some argue it was a ritual site, a place of purification where water held spiritual significance. Others point to its practical function, a public utility for a city obsessed with cleanliness, or perhaps an early prototype of a community center. The surrounding rooms, with their carefully placed niches and platforms, suggest ceremonies, but the engineering screams functionality. The truth might lie somewhere in between. Imagine a space where technology and tradition merged, where the act of bathing wasn't just about hygiene, but about harnessing water's symbolic power through cutting-edge design. The construction itself reveals secrets. The bath's walls were reinforced with wooden dowels to prevent cracking, a technique later seen in earthquake-resistant architecture. The bricks were baked to perfection, uniform in size and strength, their edges beveled to create seamless joints. Even the positioning was deliberate, aligned with the city's grid, yet slightly elevated to prevent floodwater contamination. This wasn't just building, this was engineering with foresight. And then there's the mystery of the missing instructions. How did artisans achieve this without written manuals or surviving tools? The knowledge was clearly systemic, passed down through generations, yet it left no trace in the archaeological record beyond the structure itself. When the Indus Valley faded, so did this mastery. Later baths in the region were crude by comparison, lacking the precision and durability of their predecessor. The Great Bath stands as a silent question. What other hydraulic secrets vanished when this civilization's voices fell silent? The answers might still lie buried, waiting to surface. Buried beneath the dust of Mohenjo-daro's ruins, archaeologists uncovered something extraordinary: tiny, carefully crafted cubes of chert, each one precisely measured to a universal standard. These weren't just stones, they were weights, part of an intricate system of measurement so accurate it could rival modern scales. The Indus Valley's merchants didn't guess or approximate. They traded with a precision that knit together an economic network stretching from the shores of Mesopotamia to the heart of Central Asia. What's astonishing isn't just the existence of these weights, it's their flawless consistency. Excavations across 5 major cities revealed weights following the same exact ratios. The smallest unit, just over 1 gram, multiplied in a perfect binary sequence, 1, 2, 4, 8, 16, 32 right up to a massive 12.7 kilograms. No deviations, no regional quirks. A merchant in Lothal could weigh out a shipment of lapis lazuli using the same weights as a trader 800 miles away in Harappa. With absolute confidence they'd agree on the numbers. Try finding that level of standardization in ancient Egypt or Babylon. The craftsmanship is equally mind-bending. These weights weren't rough chunks of rock. They were polished to smooth perfection, their edges sharp, their surfaces flawless. Many were made from chert, a dense stone resistant to chipping or wear, ensuring they'd last generations without losing accuracy. Some larger weights even had grooves for lifting, hinting at a system designed for daily use, not just ceremonial show. But here's the real kicker: when tested against modern scales, many of these ancient weights were accurate to within 1%. That's not close enough. That's lab-grade precision from a civilization without digital calipers or laser measuring tools. How did they achieve this? No instruction manuals survive. No carvings depict workshops where artisans calibrated these tools. The knowledge seems to have been passed down through a guild-like system where expertise was so tightly controlled it left no written trace. And that's what makes their disappearance so baffling. When the Indus cities declined, this system didn't evolve, it vanished. Later cultures in the region, like the Vedic peoples, reverted to inconsistent, locally variable measures. Even the Greeks and Romans, for all their engineering prowess, never matched this level of metrological harmony across an empire. Perhaps most intriguing is what these weights reveal about the Indus Valley's worldview. This wasn't just about fairness in trade. It was a cultural obsession with order, a mathematical rhythm etched into every transaction. The binary progression suggests an understanding of exponential growth, while the absence of fractional weights implies transactions were designed for bulk exchanges, possibly state-controlled. Some researchers speculate the system was tied to taxation or tribute, with the heaviest weights reserved for civic infrastructure projects. Others see evidence of an early commodity currency, where goods like grain or cotton were exchanged by weight rather than bartered haphazardly. One thing's certain: this was a society that trusted numbers more than words. While other civilizations wrote exhaustive legal codes to settle trade disputes, the Indus people let their weight speak for them. The stones didn't just measure goods, they measured integrity. And when that system collapsed, it took with it a vision of commerce so advanced we're only now beginning to grasp its brilliance. Every perfectly polished cube is a silent challenge. How do you build an economy without rulers, without laws, just the unshakable certainty of a shared standard? The answer might rewrite what we know about the roots of globalization. Among the most tantalizing mysteries left by the Indus Valley Civilization are the thousands of tiny soapstone seals etched with strange, elegant symbols, a script that has stubbornly resisted decipherment for over a century. These aren't random scratches. The markings follow clear patterns with recurring combinations of signs that suggest structure, even grammar. Some symbols resemble animals, bulls, elephants, unicorns, while others are abstract, loops, slashes, and shapes that hint at mathematical precision. But here's what baffles scholars. Despite decades of effort, no one has cracked the code. Is it a lost language, a system of ownership marks, or something far more unexpected? The seals themselves are miniature marvels, carved with exquisite detail. They were likely pressed into clay or wax to mark goods like ancient barcodes. Many bear the same sequences of symbols paired with specific animal motifs, implying these weren't just decorative. They conveyed meaning. Some researchers argue the script is logosyllabic, like cuneiform or hieroglyphs, where signs represent both sounds and ideas. Others propose it's purely symbolic, a non-linguistic system for recording trade transactions or religious invocations. The truth might be stranger. Unlike Egyptian or Mesopotamian scripts, which evolved into full writing systems, the Indus symbols show no clear development over time. They appear fully formed, as if the knowledge arrived complete then vanished without a trace. What makes this silence so deafening is the sheer volume of evidence. Over 4,000 inscribed objects survive, yet without a Rosetta Stone. A bilingual key, the symbols guard their secrets fiercely. Computer analysis reveals statistical patterns resembling language, but attempts to link it to known tongues, from Sanskrit to ancient Tamil, hit dead ends. Some theorists even speculate it wasn't meant to be read at all, but functioned as a mnemonic device, triggering oral recitations known only to initiates. Imagine a society where knowledge wasn't stored in texts, but in living memory reinforced by these enigmatic tokens. The implications are staggering. If this isn't writing as we understand it, but something else entirely, we might be missing a whole dimension of ancient communication. Later Indian scripts like Brahmi show no clear lineage to these symbols, as if the Indus system was erased and reinvented from scratch. Yet the seals persist, whispering of a time when meaning wasn't just written, it was performed, perhaps tied to rituals or trade ceremonies we can scarcely reconstruct. Every undeciphered stroke is a locked door, and behind it could be mundane records or revelations that append history. Until we find the key, these silent stones keep their last secret, not just what they say, but why they were meant to be forgotten. Among the most striking artifacts of the Indus Valley are the small, square seals adorned with elaborate animal carvings, creatures frozen in stone with such lifelike detail. You can almost hear the snort of a bull or the sway of an elephant's trunk. These aren't just decorative trinkets. Each seal is a miniature masterpiece, measuring barely an inch across yet packed with symbolism that has fueled debates for decades. Take the famous unicorn motif, a bull-like creature with a single, stylized horn appearing on over half the recovered seals. Is it a mythological beast, a symbolic hybrid, or evidence of a now extinct species? The answer might lie in how these seals were used, and for that, we need to step into the bustling markets of the ancient Indus. Picture a trader in Lothal unloading a shipment of carnelian beads from the docks. Before the goods change hands, he presses his personal seal into a clay tag, imprinting it with that unmistakable unicorn alongside a row of cryptic symbols. This isn't just a signature, it's a guarantee. The seal authenticates the origin, quality, or even the contractual terms of the trade, much like a notary's stamp today. Archaeologists have found these clay ceilings still clinging to cords and bundles in Mesopotamian ports, proving these tiny emblems traveled thousands of miles as part of an intricate trade network. The animals, then, might have served as clan insignias or guild trademarks, instantly recognizable even to those who couldn't decipher the accompanying script. But there's a twist. Not all animal motifs were equal. While the unicorn dominates, other seals feature elephants, tigers, rhinos, and even crocodiles, animals tied to specific regions or ecosystems. A seal with an elephant might signal goods from forested areas, while a rhinoceros could denote products from the marshy Indus Delta. This suggests a visual language bridging linguistic barriers, a system where the creature itself conveyed meaning beyond ornamentation. Yet the absence of domesticated animals like horses or cows raises questions. Were these wild creatures chosen for their symbolic power? Did they represent deities or natural forces invoked to protect the transaction? The religious angle is just as compelling. Some seals depict animals in ritualistic poses, a buffalo confronting a spear-wielding figure, or a horned deity seated cross-legged amid beasts. These scenes echo later Hindu and Buddhist iconography, where animals serve as divine mounts or cosmic symbols. Could the unicorn be an early avatar of Shiva's bull Nandi? Or a prototype of the mythical creatures in Vedic hymns? The parallels are tantalizing, but without deciphered texts, we're left connecting dots across a gulf of centuries. What's undeniable is the craftsmanship. These seals were carved with tools fine enough to etch individual hairs on a bull's dewlap or the scales on a crocodile's back. The artists worked with magnifying lenses. Archaeologists have found traces of optical aids in workshops and used a drilling technique so precise it left almost invisible perforations. This wasn't folk art, it was a high-status craft possibly monopolized by a secretive guild. And when the Indus cities faded, so did this tradition. Later Indian seals were cruder, their animals less anatomically precise, as if the knowledge of how to breathe life into stone had evaporated overnight. Perhaps the greatest mystery isn't what these seals meant, but why their language, both visual and scriptural, was so abruptly abandoned. Later civilizations borrowed pot designs, brick sizes, and even city layouts from the Indus people, but not these symbols. It's as if the animals carved into these stones were meant to stay silent, their messages dying with the hands that held them. Every seal is a locked box, and inside lies not just a lost technology, but a lost way of seeing the world. Deep in the ruins of the Indus Valley, buried beneath layers of forgotten history, lie metal objects that shouldn't exist, not for their time. Take the famous bronze dancing girl of Mohenjo-daro. Just 4 inches tall, she stands poised in an eternal twist, her slender limbs frozen in motion, her necklace still visible in exquisite detail. But what's truly remarkable isn't just her artistry, it's the metal itself. Analysis reveals an alloy of 95% copper and 5% tin, a near-perfect bronze ratio that modern metallurgists would struggle to replicate without precise instruments. This wasn't a lucky accident. Across hundreds of artifacts, from fishhooks to chisels to intricate figurines, the Indus Valley's metalworkers maintained this same staggering consistency, crafting alloys with a purity that rivals modern industrial methods. How did they do it? Unlike later civilizations, which left behind smelting manuals or workshop inscriptions, the Indus people's metallurgical secrets vanished without a trace. But the clues are there. Their crucibles, unearthed in places like Lothal, show evidence of controlled, multi-stage firing techniques capable of reaching temperatures over 1,000 degrees Celsius, hot enough to separate impurities while preserving the perfect tin-copper balance. Some vessels bear residue of flux materials, likely used to draw out contaminants, while others suggest they mastered the art of alloy blending, mixing ores from distant regions to achieve specific properties. A dagger found in Harappa, for example, contains trace amounts of arsenic deliberately added to strengthen the blade without making it brittle. this wasn't just trial and error. This was chemistry in action, centuries before the periodic table. Even more puzzling is the sourcing. Tin, the critical ingredient for bronze, doesn't exist naturally in the Indus region. Yet somehow, these artisans secured steady supplies, possibly through trade networks stretching as far as Afghanistan or Iran, a logistical feat that implies not just technical skill, but a highly organized economic system. The metals themselves tell the story. Isotopic analysis links some copper artifacts to mines over 500 miles away, while others show signs of advanced recycling, with broken tools melted down and reforged without losing quality. This wasn't a scattered cottage industry, it was a supply chain operating with ruthless efficiency. Then there's the real head-scratcher, the near-total absence of iron. While later civilizations rushed to adopt iron for its strength, the Indus Valley clung to copper and bronze long after others had moved on. Some researchers argue their alloys were so refined, so perfectly tuned to their needs, that iron simply couldn't compete. A bronze saw uncovered in mohenjo-daro, for instance, retains a razor-sharp edge after 4,000 years, its teeth still aligned with micrometer precision. Tools like this didn't just work, they elevated craftsmanship to an art form, enabling the precise stonework and intricate carvings found throughout the cities. But here's the twist: when the civilization declined, this metallurgical genius didn't evolve, it collapsed. Later cultures in the same region produced cruder, less consistent metalwork, as if the knowledge had been erased. Even the famed Delhi iron pillar, crafted centuries after the Indus Valley's peak, owes its rust-resistant properties to an entirely different technique, one that couldn't replicate the bronze perfection of the dancing girl. What happened? Was the expertise too tightly held by guilds that disbanded? Did the collapse of trade networks cut off access to key materials? Or was there something about their society, their understanding of materials, their reverence for craft, that couldn't be passed down? Every flawless artifact is a silent challenge, daring us to reverse engineer a technology that vanished without a manual. The answers might still be hidden in the molecular structure of those ancient alloys, waiting to be decoded. Hidden among the ruins of the Indus Valley are tiny, glittering treasures that defy explanation. Carnelian beads so perfectly drilled, they look like they were crafted by laser rather than ancient hands. These weren't just ornaments, they were feats of engineering, each bead pierced with holes barely a millimeter wide, running dead straight through lengths of stone so hard, modern jewelers need diamond-tipped tools to replicate the effect. Some of these beads stretch longer than a finger, their interiors polished smooth as glass, with no trace of tool marks or wobble. How did artisans working 4,000 years ago achieve precision that would challenge today's machinery? The answer lies in a lost technology so advanced, we're still piecing together how it worked. Start with the raw material carnelian, a brittle, fiery red quartz that shatters easily under pressure. To shape it, Indus craftsmen didn't just bash away with crude chisels. Evidence from workshops in mohenjo-daro reveals a multi-step process that began with heating the stone in kilns, a technique that softened the carnelian just enough to carve without cracking. Then came the drilling. Archaeologists have found tapered copper drills coated in an abrasive paste, likely crushed emery or quartz powder, that functioned like ancient sandpaper. But here's the genius: these drills weren't hand-cranked. Microscopic analysis of bead interiors shows spiral grooves so uniform, they suggest the use of a bow-driven lathe, a tool that would have allowed the artisan to maintain constant, controlled rotation. Picture a craftsman drawing a bow back and forth like a violin string, spinning the drill bit at speeds precise enough to bore through rock without shattering it. The real magic, though, was in the finishing. After drilling, the beads were polished with a paste so fine, modern spectrometers detected residue of crushed pumice and tamarind natural acids that gave the carnelian its signature glossy sheen. But the piece de resistance, the holes themselves, many beads show no tapering, meaning the drill maintained exact diameter from entry to exit, a near impossible feat without guides or stabilizing mechanisms. Some theories suggest they used hollow reeds or bamboo shafts lined with abrasives, acting as primitive drill presses. Others point to recovered stone molds that may have held beads at perfect angles during drilling. Whatever the method, the consistency is mind-boggling. String a dozen beads together and their holes align like a strand of DNA, each one mirroring the next with machine-like perfection. What's even more astonishing is the scale. Excavations at Lothal uncovered a single workshop with over 30,000 beads in progress, evidence of mass production centuries before factory concepts emerged. Traders carried these beads as far as Mesopotamia and Egypt, where they were prized as luxury items. A single strand could buy a herd of goats in ancient Ur, their value tied not just to beauty but to the sheer impossibility of their craftsmanship. Later cultures, including the Romans, attempted carnelian beads but never matched the Indus Valley's precision. Most showed jagged drill marks or uneven bores, stark reminders of how much knowledge vanished. The true loss isn't just the technique, it's the underlying knowledge. Today's experiments with replica tools show that drilling a single bead this way could take weeks of painstaking effort. Yet Indus workshops produced them by the thousands. This suggests a highly specialized labor force, possibly even child artisans with slender fingers suited to delicate work. But with no written records, we're left guessing how skills were taught or innovations shared. When the civilization declined, the secrets of those flawless holes disappeared too. Later Indian beads reverted to simpler methods. Even the famed gem cutters of the Mughal Empire couldn't replicate the precision. Perhaps the most haunting question isn't how they did it, but why. These beads held no functional advantage over cruder versions. Their perfection seems almost excessive unless you consider what they represented. In a society that standardized bricks, weights, and city grids, maybe the beads were another expression of an obsession with order, a cultural fingerprint etched in stone. Or maybe they were more. Some researchers note that the longest beads, with their needle-straight channels, resonate at specific frequencies when threaded and struck, hinting at forgotten musical or ritual uses. Every perfect hole is a silent echo of a world that valued precision not just for utility, but as a language unto itself. While the world was still wrapped in animal hides and rough flax, the people of the Indus Valley were spinning threads so fine they rival modern cotton fabrics. Evidence from Mehrgar pushes the origins of cotton cultivation back to 6000 BCE, nearly 4,000 years before Egypt or Mesopotamia adopted the plant. But this wasn't just early farming. This was an entire textile revolution, complete with advanced weaving techniques, dyeing methods, and even trade networks that turned cotton into a coveted luxury across ancient civilizations. The real marvel lies in the details. Archaeologists excavating Mohenjo-daro uncovered spindle whorls, small, weighted discs used for spinning thread, so precisely balanced they could produce yarn of astonishing thinness. Microscopic analysis of surviving fabric impressions reveals weave densities up to 50 threads per inch, comparable to high-quality bed linens today. And the cotton itself, genetic studies suggest the Indus Valley domesticated a local strain of Gossypium arboreum, selectively breeding plants for longer, stronger fibers ideal for fine textiles. This wasn't accidental cultivation. This was bioengineering millennia before the term existed. But how did they process it? Unlike wool or flax, cotton requires removing stubborn seeds, a task so labor-intensive Illy Whitney's 19th century cotton gin revolutionized the industry. Yet Indus artisans cracked this challenge with a tool called a charka, an early spinning wheel featuring tapered rollers that separated fiber from seed with remarkable efficiency. Clay models of these devices found in household ruins show they were common enough for domestic use. Imagine entire neighborhoods humming with the whir of spinning wheels, transforming balls into yarn as routine as baking bread. The innovation didn't stop at spinning. Excavated dye vats in Lothal contained traces of madder root and indigo, chemicals still used today for vibrant reds and blues. Some fabric impressions show intricate patterns, suggesting resist dyeing techniques like tie-dye or batik. And then there's the trade. Mesopotamian tablets praise meluha cloth, likely Indus cotton, as a prestige item, while seals depicting draped figures hint at tailored garments far beyond simple wraps. A single fragment from Oman, stamped with Indus motifs, proves these textiles traveled farther than the civilization's bricks or beads. Here's what's truly baffling. When the Indus cities declined, this expertise didn't diffuse, it condensed. Later Indian textiles, though renowned, lacked the systematic scale of Indus production. The charkha vanished until medieval times, and cotton spread westward, stalled for centuries. Was their knowledge guarded by guilds that disbanded? Did climate shifts disrupt cotton farming? Or was their true break through not the technology itself, but the social organization that sustained it? The threads may have frayed, but their legacy lingers, woven into history's fabric, waiting to be unraveled. Buried along the Gujarat coast lies a structure so advanced, it rewrote history's timeline of maritime engineering, the ancient dockyard of Lothal. Stretching over 700 feet long and 40 feet wide, this wasn't just a dugout basin. It was a tidal dock designed to harness the moon's pull, filling and draining with the precision of a modern lock system. The brick-lined channel connected directly to the Sabarmati River, allowing ships to glide in at high tide, unload goods, and depart smoothly as the waters receded, all without manual intervention. Compare that to contemporary Egyptian or Mesopotamian ports, where boats had to be dragged ashore or anchored precariously in open water. Lothal's dock wasn't just functional, it was a hydrodynamic masterpiece, anticipating problems engineers wouldn't face again until the age of steamships. What's truly staggering is the dock's resilience. The walls, built from kiln-fired bricks set in gypsum mortar, still stand millennia later, resisting erosion from saltwater that would have crumbled lesser materials. At the entrance, a cleverly designed spillway prevented flooding during storms, while wooden gates, evidenced by post holes, could isolate the dock for repairs. Even more impressive, the entire structure was leveled to within inches of perfect flatness using nothing but primitive surveying tools. Archaeologists found terracotta models of the dock in nearby ruins, suggesting it was planned with scaled prototypes, an innovation thought to have originated with the Romans 2,000 years later. But Lothal wasn't just about engineering prowess. It was the pulsating heart of a trade network stretching from Oman to Mesopotamia. Excavations revealed warehouses stacked with exotic goods, Persian Gulf seals, African ivory, Mesopotamian copper, and even rare timbers from the Deccan Plateau. The dock's strategic position let it exploit monsoon winds, with ships departing as seasonal winds shifted, a practice later formalized as the Hypalus route by Greek sailors. Cuneiform tablets from mention Meluha boats, laden with ivory, gold, and carnelian goods traceable to Lothal's workshops. The real mystery lies in the logistics. How did Lothal's sailors navigate open oceans without compasses or astrolabes? Artifacts hint at answers: etched shell rings that may have been primitive sextants, clayed discs with star-like patterns, and even a recovered compass made of magnetite ore. But the most compelling clue is genetic. Studies of modern Indian Ocean populations show shared DNA markers between Lothal's region and coastal Yemen, evidence of centuries of intermingling seeded by these ancient voyages. When the Indus civilization declined, the dock didn't just fall into disuse, it was deliberately filled in, as if to seal away its secrets. Later Indian ports, like those of the Mauryan Empire, reverted to simpler designs. The tidal dock's principles wouldn't reappear until medieval Europe. Perhaps the greatest loss isn't the bricks and gates, but the knowledge of how to dance with the tides, a partnership of human ingenuity and natural rhythm that vanished as suddenly as the receding waters. Walking through the ruins of Mohenjo-daro or Harappa, one thing becomes immediately clear: this wasn't just a collection of huts or simple dwellings. These were cities built with foresight, their streets laid out in perfect right angles, their blocks divided with mathematical precision. The Indus Valley Civilization didn't just build homes, they engineered entire urban ecosystems, complete with multi-story structures that suggest a level of architectural sophistication unmatched in the ancient world. What's staggering isn't just the scale of these buildings, but the fact that their designs adhered to a master plan, one that remained consistent across hundreds of miles of civilization. Take the house of a wealthy merchant in Mohenjo-daro. Unlike the haphazard sprawl of Mesopotamian or Egyptian cities, this structure rose 2, sometimes 3 stories high, with a standardized staircase leading to upper floors, each step the same height, each landing perfectly proportioned. The ground floor often housed workshops or storefronts, while living quarters occupied the upper levels, a vertical division of space that feels eerily modern. But here's what's truly remarkable. These weren't standalone marvels. Entire neighborhoods were constructed this way, with shared walls between homes forming continuous facades along the streets. This wasn't just architecture, it was urban planning on a scale the world wouldn't see again until the Roman Empire. The materials tell their own story. Uniformly sized bricks, baked to perfection, formed load-bearing walls thick enough to support multiple floors. Some buildings incorporated wooden beams for additional stability, while others featured intricate corbelling, a technique where each layer of bricks slightly overhangs the one below, distributing weight without the need for arches. Archaeologists have even found evidence of cantilevered balconies jutting out over the streets below, their supports cleverly hidden within the walls. These weren't crude experiments, they were calculated structural solutions, honed through generations of trial and error. Yet the real genius lies in the city's organization. Streets ran north-south and east-west in a grid so precise, modern surveyors have found deviations of less than a single degree over entire blocks. Main thoroughfares stretched up to 30 feet wide, allowing carts and pedestrians to flow smoothly, while smaller alleys branched off like capillaries, ensuring every home had access. Drainage channels ran beneath these streets, connected to each household's private waste chutes, a sanitation network integrated seamlessly into the urban fabric. What does this reveal about their society? For starters, it hints at a centralized authority with the power to enforce building codes and land use. Someone dictated where homes could be built, how high they could rise, and even where the drains would run. But unlike the top-down decrees of pharaohs or kings, the Indus system feels almost democratic. There are no grand palaces dwarfing the homes of commoners, no evidence of slums or shantytowns. Even the largest buildings seem designed for communal use: granaries, baths, assembly halls, suggesting a culture that valued collective well-being over individual Chinese letter. The most haunting question isn't how they built these cities, but why the knowledge vanished. Later Indian urban centers, like those of the Vedic period, abandoned the grid for organic, winding layouts. Multi-story construction became rare, and the meticulous standardization of bricks gave way to irregular rubble masonry. It's as if the entire concept of planned cities was erased from memory. Perhaps the answer lies in the Indus Valley's collapse, a gradual decline that scattered its builders before they could pass on their techniques. Or maybe the secret wasn't just in the bricks and blueprints, but in the social cohesion that made such coordination possible. When that unity fractured, the cities couldn't be rebuilt. Today, wandering those empty streets, you can still see the ghostly imprints of staircases leading nowhere, of walls that once supported thriving upper floors. They stand as silent witnesses to a time when urban living wasn't just functional, it was visionary. The real lost technology here isn't just the architecture itself, but the understanding that a city could be more than a collection of buildings. It could be a living machine, every part working in harmony, an idea so ahead of its time we're still chasing it millennia later. At first glance, the windowless walls of Mohenjo-daro's homes seem counterintuitive. Why block out light and air in a sweltering river valley? But look closer, and you'll spot narrow slits near the ceilings and peculiar clay ducts running through the bricks. These weren't structural flaws, they were deliberate cooling systems, a Bronze Age answer to air conditioning that harnessed the physics of airflow centuries before the concept of thermodynamics existed. The secret lay in something called the Venturi effect. As hot wind rushed through those narrow vents, it accelerated, creating a pressure drop that sucked cooler air from shaded courtyards below. The result, a constant breeze channeled through homes without a single moving part. Some houses took this further with badgers or wind-catching towers similar to those seen in later Persian architecture. These rooftop structures funneled prevailing breezes downward into interior chambers, where earthenware jars filled with water added evaporative cooling. The science is impeccable. As air passed over the jar's moist surfaces, it shed heat, dropping temperatures by several degrees. Excavations even revealed underground cooling tunnels in wealthier districts, where air was preconditioned by the Earth's natural insulation before entering living spaces. This wasn't just ventilation, it was climate control engineered with an intuitive grasp of fluid dynamics. What baffles researchers is the uniformity of these features. From the smallest workers' dwelling to the largest courtyard house, variations of this system appear, suggesting cooling wasn't a luxury but a standardized necessity. The Indus people didn't just adapt to their environment, they hacked it, turning passive materials into active thermal regulators. Modern tests using replica structures confirm their effectiveness. Interiors stayed a full 10 degrees cooler than outside peak temperatures, rivaling the performance of early 20th century cooling systems. Yet the most intriguing possibility lies in the city's orientation. Mohenjo-daro's main streets align precisely with the summer solstice winds, a deliberate urban planning choice that turned entire neighborhoods into giant wind tunnels. When monsoon patterns shifted centuries later, this delicate balance may have collapsed, rendering the systems useless. Later Indian architecture abandoned these features, replacing them with open courtyards and thick walls, a step backward in thermal engineering. The knowledge didn't just fade, it evaporated as completely as the water in those cooling jars, leaving behind only silent ducts begging to be decoded. Among the most enduring mysteries of the Indus Valley are their ceramics, not just simple clay pots, but vessels so perfectly proportioned, so strikingly decorated, they look like they could have been crafted yesterday. This wasn't primitive pottery, it was mass-produced art fired in kilns capable of temperatures that would make a Roman furnace blush. Take the iconic black on red ware, delicate bowls and jars adorned with geometric patterns in glossy black pigment, their surfaces buffed to a sheen that survived millennia underground. The precision is staggering. Spin one of these pots on a flat surface, and they rotate without wobbling, evidence of wheel-throwing techniques so refined. They rival industrial pottery wheels of the 19th century. The real marvel lies in the kilns themselves. Excavations at sites like Kalibangan reveal massive, twin-chambered structures with baffles to control airflow, a design that allowed temperatures to soar past 1,000 degrees Celsius, hot enough to vitrify clay into near-stone durability. But here's the twist, these weren't just hotter kilns, they were smarter. Stacking grooves inside the chambers show potters fired dozens of vessels simultaneously, while strategic placement of fuel vents created oxidizing and reducing zones in the same firing cycle. That's how they achieved their signature colors. The iron-rich clay turned ruby red in oxygen-rich areas, while sealed sections starved of oxygen produced the Inkai black carbon core effect. This wasn't guesswork, it was ceramic chemistry in action centuries before the periodic table. Even more puzzling are the glazes. A handful of excavated shards bear a mysterious vitreous coating, not the lead-based glazes of later Mesopotamia, but something far more unusual. Spectrographic analysis detected traces of plant ash and crushed quartz, ingredients that, when fired at precise temperatures, form a natural glass. The technique resembles later Egyptian faience, but with one crucial difference. Indus glazes appear only on select ceremonial objects, suggesting they held the recipe close, possibly as a trade secret. Some vessels even show multicolored drips, hinting at experiments with metallic oxides that wouldn't be rediscovered until the Renaissance. What truly sets Indus pottery apart, though, is its ubiquity. From fishing villages to major cities, every household had access to wheel-thrown ware, all conforming to the same high standards. Archaeologists find near-identical water jars in sites 500 miles apart, their volumes matching standardized weight systems. This wasn't just skilled craftsmanship, it was an entire economy of scale, with centralized workshops supplying regions via river trade. Yet when the civilization declined, the knowledge didn't diffuse. Later cultures in the same region reverted to hand-coiling techniques, their kilns smaller, their pots cruder. The wheel kept turning, but the mastery had vanished, leaving behind only those perfect spinning bowls, a silent testament to a technology that spun itself into oblivion. Beneath the sun-baked plains of the Indus Valley, an agricultural revolution quietly unfolded, one that turned unpredictable floods into life-giving abundance. While other river civilizations struggled with famine when waters rose or receded, the Harappans didn't just endure nature's whims, they engineered around them. Their fields weren't haphazard plots but carefully designed grids, elevated on mud brick platforms to protect seedlings from sudden deluges. Archaeologists have uncovered vast networks of interconnected ridges and furrows at sites like Kalibangan, arranged in chessboard patterns that allowed excess water to drain while trapping nutrient-rich silt, a system so effective modern rice paddies still use similar techniques today. But flooding was only half the battle. The real genius lay in their crop cycles. Soil analysis reveals a sophisticated rotation system where wheat and barley thrived in winter, followed by drought-resistant millets in summer, with pulses like chickpeas planted to replenish nitrogen between harvests. This wasn't guesswork. Charred seeds found in storage jars show deliberate selection, plumper grains saved for planting, weed varieties systematically eliminated over generations. They even practiced early forms of intercropping, with mustard plants grown alongside cereals to repel pests naturally. The yields were staggering. Estimates suggest Mohenjo-daro's granaries could hold enough grain to feed 40,000 people for a year, all without plows pulled by beasts of burden, which curiously never appear in their artwork. Water management reached near miraculous levels. Beyond the famous city drains, the Indus people engineered sprawling countryside irrigation with calibrated sluice gates and serpentine canals that mimicked the river's natural curves to reduce erosion. At Dolavira in the arid Thar Desert, they built cascading stone tanks that harvested every drop of monsoon rain, channeling it through gravity-fed terraces to fields below. Some reservoirs still hold water after 4,000 years, their limestone linings preventing seepage, yet the most baffling innovation might be their flood forecasting. At Harappa, alignments of standing stones correspond to solstice markers, suggesting they tracked seasonal shifts to predict river surges. Clay tablets bear tally marks that researchers believe recorded water levels, an ancient hydrological dataset. When the rains failed, they tapped underground aquifers using filter wells, cylindrical pits lined with porous pots that purified water as it seeped in, a concept now fundamental to modern wells. Why did these techniques vanish? Later Vedic texts describe slash and burn farming, a stark regression. Perhaps the answer lies in specialization. Indus agriculture relied on collective labor and shared infrastructure. As cities fragmented, that cohesion dissolved, taking with it the knowledge of how to turn floodwaters into fertility. Today, as climate change reshapes our own farmlands, those buried fields whisper urgent lessons about bending nature's chaos to human ingenuity. Among the great civilizations of the ancient world, Egypt with its pyramids, Mesopotamia with its ziggurats, Mesoamerica with its towering temples, the Indus Valley stands apart for what it lacks. No monumental shrines, no gargantuan statues of gods, no inscriptions declaring divine kingship, just empty space where we'd expect grand religious architecture to dominate the skyline. This absence isn't an accident of preservation. It's a deliberate void, one that forces us to rethink everything we assume about ancient spirituality and power. Consider the evidence. In Mohenjo-daro's meticulously excavated ruins, not a single structure can definitively be called a temple. The so-called Great Bath might have had ritual significance, but compare it to the towering step pyramid of Djoser built around the same time. One dwarfs the landscape as an act of devotion, while the other blends into the city grid, functional and unobtrusive. Even the few seals depicting possible deities show them seated among animals, not enthroned in gold-covered halls. If religion dominated Indus life, why didn't it manifest in stone the way it did for every other contemporary culture? One radical theory suggests the answer lies in their urban design itself. The city's egalitarian layout, no palaces looming over slums, no temples hoarding wealth, hint at a society where spiritual practice was decentralized. Imagine faith woven into daily routines, household shrines hinted at by small fire altars found in courtyards, purification rituals tied to those advanced drainage systems, sacred symbolism embedded in trade seals rather than carved onto temple walls. Their spirituality might have been as practical as their plumbing, an intimate force shaping actions rather than an institution demanding towering monuments. But here's the twist: this lack of temples could also reflect a profound separation of authority. In Egypt and Mesopotamia, priests and kings were often one, their power legitimized by divine spectacle. The Indus elites, if they existed at all, left no depictions of themselves receiving blessings from gods, no inscriptions claiming heavenly mandates. Even their citadels, once thought to house rulers, show no evidence of royal living quarters. Perhaps governance here wasn't about spectacle but silent efficiency, with leaders more concerned with standardizing brick sizes than erecting monuments to their own glory. The most tantalizing clue comes from what replaced these cities. When Vedic culture later rose in the same region, its texts brim with elaborate fire rituals and forest-dwelling sages, yet say nothing of forgotten temples. If the Indus people had worshipped in grand structures, wouldn't their successors have repurposed or at least mentioned them? The silence speaks volumes. Their sacred spaces might have been transient open-air platforms, riverbanks at dawn, the rhythmic act of crafting a perfect bead, a religion so woven into the fabric of living, it needed no stone to make it real. What haunts us isn't just the absence of temples, but what it implies about human societies. For 5,000 years, we've assumed civilizations must declare their beliefs in marble and gold. The Indus Valley whispers another possibility, that the deepest spirituality leaves no footprint at all. Beneath the streets of Mohenjo-daro ran a hidden marvel, a network of brick-lined sewers so advanced they wouldn't be matched until the 19th century. While medieval European cities tossed waste into open gutters, and even Rome's famed Cloaca Maxima was little more than a glorified ditch, the Indus people engineered something revolutionary, a closed, gravity-fed sanitation system that kept their crowded metropolis free from the plagues that ravaged other ancient cities. Picture this: every home had a dedicated waste chute connecting to underground channels that sloped precisely half an inch per foot, ensuring water flushed debris toward main drains without stagnation. These weren't dark, collapsing tunnels either. Archaeologists found carefully spaced manholes with stepped bricks, allowing cleaners access while preventing foul air from rising, an early form of sewer gas management that predates modern trap systems by millennia. The real innovation lay in their foresight. Main drains ran beneath streets rather than buildings, avoiding structural damage from erosion. Curved junctions reduced blockages, while sedimentation tanks filtered solids before water entered river outflows, a primitive treatment system that protected downstream communities. Some channels even featured self-sealing stone lids that lifted during flash floods, preventing backups without human intervention. This wasn't just plumbing, it was public health engineering on a scale that wouldn't reappear until Louis Pasteur's germ theory. Remarkably, analysis of waste deposits shows lower parasite loads than in contemporary Egyptian or Mesopotamian cities, proving these systems actually worked. What's truly baffling is how the knowledge vanished. When later cultures like the Vedic people built over these ruins, they abandoned the underground networks, reverting to open pits. The concept of citywide sanitation wouldn't resurface until London's sewer revolution in the 1800s. Perhaps the answer lies in maintenance. In dust sewers required collective upkeep by trained crews. As social order fragmented, so did the expertise to sustain this delicate balance between civilization and biology. Those empty channels still whisper a warning: technology alone isn't enough. Without the society that nurtures it, even the greatest innovations can slip back into the earth. Tucked away in the ruins of Harappa and Mohenjo-daro, buried beneath layers of ancient dust, lie thousands of small, unassuming terracotta figurines, some no larger than a thumb, others standing tall as a forearm. At first glance, they seem simple, crudely molded animals, plump female forms with exaggerated features, even tiny carts with movable wheels. But look closer, and these humble clay objects unravel into one of the Indus Valley's most tantalizing mysteries. Were they children's playthings, sacred objects of worship, or something far more unexpected? Take the so-called dancing girls, figurines frozen mid-motion, arms arched, hips tilted, their lively poses belying their static material. Some archaeologists argue these were nothing more than toys, pointing to their discovery in domestic spaces alongside miniature pots and tiny spinning tops. The movable limbs of animal figurines, like bulls with nodding heads or monkeys with swinging tails, suggest interactive play. But here's the catch: many of these figures show signs of deliberate breakage, their edges worn smooth from handling, as if passed down through generations. Could something meant for fleeting childhood entertainment hold such lasting value? Then there are the enigmatic mother goddess statues, full-bodied female forms with intricate headdresses and pronounced curves, often found near hearths or grain storage areas. Their exaggerated anatomy has led some to interpret them as fertility symbols, perhaps precursors to later Hindu deities like Shakti, but not so fast. Recent studies reveal striking variations. Some goddesses wear elaborate necklaces, others clutch infants, while a few even perch on thrones. If these were purely religious, why the lack of standardization? Compare them to the rigidly uniform deities of ancient Egypt or Mesopotamia, and the contrast is stark. Maybe these weren't idols at all, but ancestor representations, tangible connections to lineage in a society that left no written genealogies. The plot thickens with figurines that defy easy categorization. Miniature cattle, painstakingly detailed with humps and horns, appear in clusters near city gates, possibly ritual offerings for safe journeys. A peculiar set of masked humanoids with slit eyes and beak-like noses hint at theatrical or shamanic traditions. Even more puzzling are the terracotta models of flat-bottomed boats, complete with oar holes and central cabins, found far inland. Were these votive deposits for merchants, teaching aids for apprentice sailors? The sheer diversity suggests these objects wore many hats, serving purposes that shifted with context. Perhaps the most radical theory comes from the figurine's construction itself. Unlike the mass-produced pottery or beads, no two terracottas are truly identical. Their clay varies in texture and temper, some fired hard as brick, others left sun-dried and fragile. This inconsistency hints at decentralized production, maybe even household crafting, where each piece carried personal meaning. Some bear fingerprints preserved in the clay, tiny ridges pressed into the surface by long-vanished hands. These weren't anonymous commodities, they were intimate creations shaped by individuals for reasons we can only guess at. When the Indus cities faded, so did this terracotta tradition. Later cultures in the region made figurines, but with rigid styles tied to specific deities. The playful variety, the fluidity of purpose all gone. What remains are these silent clay witnesses holding secrets in their hollow bodies. Were they toys that became talismans, idols that doubled as teaching tools? The answer might be simpler and more profound than we've imagined. Perhaps they were all these things at once, reflecting a world where the sacred and the everyday weren't at odds, but woven together as tightly as the fibers in a terracotta mold. Every unbroken figure is a question waiting to be asked, not just about what they were, but about the hands that shaped them and the lives they touched. Among the silent remnants of the Indus Valley, there are whispers of sound, hints of a civilization that didn't just build and trade, but made music. Picture this, a tiny terracotta figurine, no taller than your finger, cradling a drum between its hands. Another strikes a pose with arms raised, as if caught mid-dance to an unheard rhythm. These aren't just artifacts, they're frozen moments of a lost auditory world. While no intact instruments survive, the clues they left behind suggest a culture steeped in harmony, where music wove through daily life from ritual to recreation. The most compelling evidence comes from those enigmatic figurines. Excavations across Mohenjo-daro and Harappa have uncovered small clay models of women holding circular objects, some flat like tambourines, others deeper, resembling hourglass-shaped damru drums still used in South Asia today. One particularly striking figure from Lothal balances what looks like a harp or lute against its shoulder, its fingers splayed as if plucking strings. Then there are the dancing men, their arched postures and bent knees mirroring the kinetic energy of folk dancers, their arms often pierced with holes that may have once held miniature clappers or bells. These aren't generic poses, they're snapshots of performances, capturing instruments and movements too precise to be merely decorative. But the real proof lies in the artifacts that don't look musical at all until you listen closer. Take the hollow, bird-shaped whistles found in children's graves. Blow into them today and they still produce clear, fluting tones. Or the dozens of perforated clay balls, long dismissed as gaming pieces, until someone noticed their uncanny resemblance to ancient Greek rhombus rattles. Spin them on a string and they'd whir with a sound like rushing wind. Even the architecture hints at acoustics. The great baths, paved courtyards, and water channels could have amplified chanting or percussion, while the citadel's high walls might have served as natural sound reflectors for public ceremonies. The most tantalizing finds are the so-called musical bricks. At Dolivera, certain baked clay slabs emit metallic ringing tones when struck, their carefully controlled densities creating distinct pitches. Archaeoacoustics researchers have mapped clusters of these bricks in patterns suggesting intentional placement, perhaps part of a lithophone, an instrument played like a xylophone but made of stone. Similar tonal stones have been found near water sources, leading to theories that the Indus people might have composed melodies resonating with flowing streams, blending human artistry with nature's rhythms. What's haunting is how abruptly this musical tradition seems to end. Later Vedic texts describe elaborate chants and stringed instruments like the veena, but nothing resembling the drum-heavy iconography of the Indus figurines. No harps or lithophones appear in later Indian art for centuries. It's as if an entire sonic palette vanished, leaving only silent clay echoes of the rhythms that once moved a civilization. Maybe the answer isn't in the instruments themselves, but in how they were used not as entertainment, but as something sacred, their sounds so tied to a particular world view that when the culture shifted, the music couldn't follow. Every figurine's poised hands hold a question. How do you reconstruct a song when all that remains is the memory of a dance? Of all the mysteries left behind by the Indus Valley Civilization, none captivates the imagination quite like the recurring image of the so-called unicorn stamped across thousands of their seals. This strange, bull-like creature with its single curved horn appears on over half of all recovered seals, far more frequently than elephants, rhinos, or even human figures. But was this really a mythical beast or something far more grounded? The answer might rewrite how we see this civilization's relationship with both nature and myth. Look closely at one of these unicorn seals and you'll notice something peculiar. Unlike the fantastical unicorns of medieval Europe, this creature lacks the delicate grace of a horse. Instead, it's powerfully built with a thick neck, pronounced hump, and a body resembling the wild cattle that still roam South Asia today. Most telling of all, the horn isn't centered like a narwhal's tusk or a horse's mythical appendage. It juts diagonally from the side of the head, exactly where a bull's second horn would appear in profile. Could this unicorn simply be a two-horned animal depicted in the artistic shorthand of the time? Yet the sheer persistence of this image suggests deeper meaning. The unicorn almost always appears in the same exact pose, head lowered, flanked by a mysterious object resembling an incense burner or ceremonial standard. Some seals show it tethered to this device by ropes, while others depict it standing before what might be an altar. The consistency is ritualistic, as if this scene encoded a story or belief too vital to alter. Later Vedic texts describe sacred cattle sacrifices, while Hindu mythology reveres the bull as Shiva's mount. Could the Indus unicorn be an early prototype of these traditions, a symbolic link between earthly wealth and divine power? Then there's the economic angle. Unlike other animals on the seals, elephants associated with forests or crocodiles tied to river trade, the unicorn appears exclusively on stamp seals used in commerce. Archaeologists have found these seals pressed into clay tags attached to bales of cotton, sacks of grain, and ingots of copper. Its image may have functioned like a corporate logo, guaranteeing quality or origin. Consider this: cultures often imprint currency with revered symbols, from the Roman she-wolf to the American eagle. If the unicorn represented prosperity or trust, stamping it onto trade goods would have carried profound significance. Most puzzling of all is why this motif vanished when the cities declined. Later Indian art teems with bulls, yet none mimic the unicorn's distinctive profile. Perhaps the answer lies in the collapse of the trade networks that made these seals necessary. Without merchants needing to mark shipments, the symbol lost its purpose, and with it, the memory of what it truly represented. Every unicorn seal is a riddle wrapped in clay, challenging us to separate myth from reality in a world where the two may have been one and the same. Walking through the ruins of Mohenjo-daro, you might notice something strange. The bricks aren't just stacked. They're fused together with a material that's resisted water, wind, and time itself. This isn't ordinary mortar. It's a mysterious gypsum-based adhesive, a recipe so effective that 4,000 years of monsoons haven't washed it away. Modern labs have torn apart its chemistry, and what they've found is staggering. A mix of burned limestone, crushed clay, and just enough gypsum to create a crystalline structure that actually strengthens when damp. While most ancient mortars crumble under moisture, this one thrived on it, locking bricks together with a grip that outlasted empires. The secret lies in the gypsum's transformation. When mixed with water, it forms tough, interlocking needles of a mineral called basanite, a microstructure so dense it repels erosion like a shield. But the Indus builders didn't stop there. They added something unexpected: charred barley husks. At first glance, this seems counterintuitive. Why mix organic matter into something meant to last millennia? The answer is sheer genius. Those tiny carbon flecks created microscopic air pockets, allowing the mortar to flex ever so slightly during temperature swings or ground shifts. It's the same principle behind modern earthquake-resistant concrete, just without the steel rebar. Even more impressive is how they applied it. archaeologists have found trowel marks showing the mortar was layered in thin, even coats, never too thick, never too thin. Some joints include traces of bitumen, suggesting they sealed critical structures like wells or baths with an added waterproofing membrane, an ancient version of today's elastomeric coatings. The result, dockyards that still hold water, walls that shrug off centuries of floods, and foundations so stable, modern engineers have measured settlement rates of less than a millimeter per century. Then there's the real puzzle, the sourcing. Gypsum doesn't occur naturally in the Indus floodplains, yet somehow this civilization secured enough to bind millions of bricks across hundreds of miles of cities. Chemical fingerprints point to quarries in the distant Makran hills, meaning tons of raw material were hauled across treacherous terrain, a logistical feat that hints at organized supply chains rivaling modern megaprojects. The tragedy is in the silence that followed. When later cultures like the Mauryans built atop these ruins, they used weaker lime mortars that eroded within centuries. Even the Romans, for all their engineering prowess, never replicated this water-resistant alchemy. The knowledge didn't fade, it vanished abruptly, as if the recipe was guarded by guilds who took their secrets to the grave. Today, as rising groundwater threatens to dissolve our own concrete jungles, those ancient joints endure, whispering a lesson we're still struggling to hear. Sometimes the past holds answers the future has yet to rediscover. Scattered across the ruins of the Indus Valley, hidden among fragments of pottery and shreds of ancient cloth, lie bursts of color so vivid they seem impossible for their age. Deep crimsons that haven't faded after 4,000 years, blues as rich as the twilight sky, yellows that still glow like captured sunlight. These aren't accidental stains or natural discolorations. They're the remnants of a dying technology so advanced it turned everyday objects into masterpieces, using secrets modern chemists are still struggling to reverse engineer. Take that famous red and black pottery. The bold geometric patterns weren't just painted on. They were chemically bonded to the clay during firing, creating hues that refused to wear away even when the vessels themselves cracked. The real magic lay in their sources. While other ancient cultures relied on obvious pigments like ochre or charcoal, the Indus dyers went further, unlocking colors from the most unlikely places. That radiant purple staining a shard of fabric from Lothal. It came from a rare sea snail harvested along the Makran coast, its glands painstakingly processed to yield just a few drops of precious dye per creature. The vibrant yellow streaking a child's toy, not saffron or turmeric, but a concoction of pomegranate rind and iron-rich clay, fermented in copper vats to intensify its brightness. Even their blacks were engineered not simple charcoal, but complex blends of crushed gallnuts and iron salts that reacted chemically with wool to create shades so deep they absorbed light like velvet. What's truly baffling is the consistency. Excavations across 5 major cities revealed textiles and ceramics dyed with identical color formulas, despite being separated by hundreds of miles. A blue cotton fragment from Harappa matches a pot shard from Dolavira, down to the molecular level, proof that dyers weren't experimenting locally but following precise, standardized recipes. Some hues even required multi-stage processes. Greens, for example, were achieved by first dyeing fibers yellow with weld flowers, then over-dyeing with indigo in exact ratios to hit the perfect leafy tone. This wasn't improvisation, this was textile chemistry operating on an industrial scale, yet the most tantalizing clues come from the tools left behind. At Mohenjo-daro, archaeologists uncovered what might be history's first dye laboratory: stone mortars stained with overlapping pigments, ceramic beakers with residue of acidic fruit juices used as mordants, and even small copper stills for distilling essential oils that may have fixed colors to fabrics. One pot still held a dried brown paste that, when rehydrated, released the unmistakable musky scent of fermented indigo, proof they'd perfected the anaerobic fermentation process Europeans wouldn't rediscover until the 18th century. Other sites yielded dye notebooks, a pottery sherd scribbled with tally marks and pictograms that may have recorded dye batches like ancient recipe cards. Then there's the mystery of the missing fade. Modern natural dyes typically wash out or oxidize over centuries, but many Indus colors remain shockingly vibrant. The secret might lie in their mordant metallic salts that bond dye molecules to fibers. Analysis shows they used aluminum-rich clay to fix reds, copper verdigris for greens, and even tin compounds to brighten yellows, techniques far ahead of their time. Some fabrics show evidence of pre-treatment with oil and milk proteins, creating a molecular net that trapped dye particles. The result, colors that didn't just coat the surface but became part of the material itself. When the civilization declined, this chromatic brilliance didn't just dim, it vanished abruptly. Later Indian textiles, though beautiful, relied on simpler techniques, and many of the old recipes disappeared entirely. The sea snail purple, for instance, doesn't reappear in the region until Persian influences centuries later. Were the formulas too complex without centralized workshops? Were key ingredients lost when trade routes collapsed, or was there something about the Indus worldview, their love of coded systems, their obsession with imperishable perfection, that made these colors impossible to replicate once the culture fractured? Every vivid shard is a puzzle in polychrome, daring us to decode the alchemy behind hues that outlasted empires. What if the greatest mystery of the Indus Valley isn't how they thrived, but how they fell? Here was a civilization that mastered urban planning, metallurgy, and trade networks with peerless precision, only to vanish so completely that even their technologies slipped into oblivion. The signs of decline are etched into the archaeological record like cracks in porcelain. Once thriving cities abandoned grain by grain, workshops falling silent, those perfect standardized bricks replaced by haphazard rubble. But unraveling why this happened is like piecing together a puzzle where half the pieces are missing. Climate whispers one possible answer. Sediment cores from the Arabian Sea tell a story of shifting monsoons, cycles of devastating drought that may have turned the life-giving Indus River into a trickle. At Oliveira, archaeologists found hastily dug wells cutting through once meticulous water channels, as if desperate hands clawed for the last drops. Yet this wasn't an overnight catastrophe. The cities didn't burn, they emptied slowly like hourglasses. Some researchers argue the real blow came from environmental degradation, centuries of intensive farming and brick production denuding the landscape. The same kilns that fired those perfect bricks would have consumed entire forests, leaving soils barren and rivers choked with silt. A civilization that tamed floods may have fallen victim to its own success, engineering its ecosystem into collapse. Then there's the specter of invasion. For decades, scholars pointed to groups mentioned in later Vedic texts, nomadic tribes who might have swept in from the northwest. But the archaeological record shows no layers of ash, no mass graves, no sudden onslaught of foreign artifacts. Instead, there's a quieter unraveling. Trade routes fracturing, materials like lapis lazuli and carnelian vanishing from workshops, civic maintenance lapsing until drains clogged and streets flooded. This hints at a subtler killer, not a blade, but a breakdown. The Indus system relied on unspoken trust, standardized weights for fair trade, shared sanitation norms, collective labor for harvests and repairs. Once that trust frayed, the technologies binding it together may have become untenable. The most haunting theory isn't about disaster at all, but transformation. Perhaps the Indus people didn't vanish, they dispersed. As cities grew untenable, knowledge once centralized in guilds could have fractured into isolated villages, where metallurgists forgot alloy ratios and masons abandoned brick standards. Technologies that required massive coordination, like those tidal docks or sewer systems, simply had no place in a decentralized world. Later cultures might have absorbed fragments of this wisdom, repurposing terracotta figurines as toys or forgetting the sacred resonance of unicorn seals. What's certain is that the collapse wasn't uniform. While Mohenjo-daro dwindled, coastal towns like Lothal thrived for centuries longer, their docks still bustling with Mesopotamian traders. Some technologies persisted in reduced forms. Bead-making, for instance, carried on with cruder drills, but the system's genius lay in its interconnectedness. Take away the trade networks and there's no tin for bronze, lose the brick standards and drains crumble, break the shared language of seals and commerce stutters. The Indus Valley didn't just lose inventions, it lost the delicate web that made them possible. Perhaps the ultimate lesson lies in what wasn't rebuilt. Later societies reclaimed the land, repurposed the stones, even worshipped at old Indus sites, but never replicated their predecessors' precision. Those perfect bricks, those flawless beads, those silent scripts. They weren't just products of skill, they were products of a world that believed in order, in systems, in the invisible threads binding a civilization together. When those threads snapped, the technologies didn't just disappear, they became inconceivable. Standing stones at Dolivera cast shadows too precise to be coincidence, long, dagger-like lines that align perfectly with the rising sun during solstices, etching solar geometry into the earth with mathematical certainty. These aren't random placements. The entire city's layout seems to hum with celestial rhythm, its main avenues oriented to cardinal directions with near-perfect accuracy, while certain structures frame specific constellations visible only during harvest seasons. Archaeologists have uncovered carved tablets at Mohenjo-daro depicting clustered dots that suspiciously mirror the Pleiades, a star cluster critical to agricultural calendars across ancient cultures. But here's what's truly startling. Recent laser scans of Harappa's so-called granary reveal its ventilation shafts align not just for airflow, but to channel the light of Vega, the brightest star in the northern sky, directly onto its central platform during the summer zenith. The evidence extends beyond architecture. Tiny etched carnelian beads, no larger than lentils, bear patterns that researchers initially dismissed as decorative, until someone noticed their markings correspond to lunar phases. A cache of these beads, arranged in sequence, accurately tracks the moon's 27-day cycle across 16 months, with a single outlying bead possibly accounting for intercalary days. Even more compelling are the copper alloy rods found near Kalibangan, their lengths precisely fractioned into units matching the average variation between solar and lunar years. These weren't mere measuring sticks, they may have been computational devices, their notches and grooves allowing priests or planners to physically slide markers along calibrated tracks to predict eclipses or monsoons. What separates Indus astronomy from contemporaries like Mesopotamia's zodiac or Egypt's pyramid alignments is its subtlety. There are no towering obelisks explicitly dedicated to sun worship, no grand temples facing sacred stars. Instead, celestial knowledge seems woven into the fabric of daily life markets timed to celestial events, solstice markers disguised as city gates, lunar counters masquerading as children's toys. This might explain why later Indian astronomical texts like the Vedanga Jyotisha contain concepts eerily reminiscent of Indus artifacts yet lack any direct reference to their predecessors. The knowledge didn't vanish, it went underground, repurposed into folk traditions or ritual practices too mundane to be recorded. The most haunting clue lies in the dancing girl figurine's necklace. Its beads, arranged in a spiral pattern, mirror the Fibonacci sequence, a mathematical progression found in galaxy arms and nautilus shells. Was this mere artistic flair, or a glimpse of a cosmology that saw the universe's patterns reflected in the smallest details? Without deciphered texts, we're left chasing shadows, both literal and metaphorical, across 4 millennia. The stones still mark the solstices, the stars still shine down ventilation shafts, but the minds that orchestrated this harmony left no manual. Their astronomy wasn't carved in stone, it was written in the spaces between bricks, waiting for someone to measure the silence. Among the thousands of seals recovered from the Indus Valley, one stands apart, a tiny soapstone carving no larger than a thumbprint, depicting a horned figure seated in a posture so distinct it stops historians in their tracks. Cross-legged with heels pressed together, hands resting on bent knees, the figure's serene composure mirrors the lotus position of classical yoga, but it's the details that ignite controversy. Curving horns frame a headdress adorned with what might be a crescent moon, while surrounding animals a tiger, elephant, rhinoceros, and buffalo echo later Hindu iconography of Shiva as Pashupati, lord of beasts. Dated to around 2000 BC, this seal predates written references to Shiva by over a millennium. Is this a smoking gun proving yoga and Shaivism have roots in the Indus Valley? Or are we projecting modern beliefs onto an ancient Rorschach test? The case for proto-shiva hinges on uncanny resemblances. The figure's three faces visible in some seals where the headdress splits into triangular projections mirror Shiva's later trinity aspects as creator, preserver, and destroyer. The presence of a small, erect shape beneath the seat could represent a lingam, the phallic symbol central to Shiva worship. Even the animals hold significance. Tigers symbolize Shiva's ferocity, elephants his wisdom, and the buffalo his conquest over death in later myths. If this interpretation holds, it would mean core Hindu concepts existed in mature form centuries before the Vedas were composed, challenging the long-held theory that Shaivism evolved from Vedic Rudra worship. Skeptics counter with compelling arguments. The yogic pose might simply depict a tribal chief or shaman, as similar cross-legged figures appear in Mesopotamian and Central Asian art without spiritual connotations. The so-called lingam could be a footstool or sacrificial altar, while the headdress might signify a bull cult common in agrarian societies. Crucially, the Indus script remains undeciphered. Without accompanying text, we're left guessing whether this figure was a deity, a mortal, or something else entirely. Even the animal symbolism falters upon closer inspection. The seal's buffalo lacks the dramatic battle scenes seen in later Shiva art, and the absence of serpents key to Shiva's iconography is glaring. Perhaps the truth lies in the middle ground. The seal's composition undeniably reflects a sophisticated spiritual aesthetic, one that may have influenced later traditions without being identical to them. Modern experiments with the seal's proportions reveal hidden geometry. The figure's spine aligns with the golden ratio, while the animal's positions correspond to Vedic mandala directions. This suggests the artist worked within an established symbolic system, whether religious or proto-scientific. Notably, fire altars found at Kalibangan align with the seal's imagery. Some bear horn-like projections and are surrounded by animal bones, hinting at rituals that blended reverence for beasts, meditation, and elemental forces. The most tantalizing clue comes from archaeology's silent margins. At Mayagar, a site predating the Indus cities, excavators uncovered clay figurines in meditative poses alongside bull figurines, a possible precursor to the seal's imagery. If yoga-like practices existed here, they wouldn't have involved the complex philosophy of Patanjali's later sutras, but perhaps something more visceral. Trance states induced by rhythmic breathing or communal chanting, techniques still used by shamans worldwide. The seal's enduring power lies in its ambiguity, a frozen moment that could be the birth of a god, the portrait of a priest, or simply a craftsman's doodle. Every attempt to pin it down only makes it shimmer with more possibilities, a reminder that the past never fits neatly into the boxes we build for it. What remains is the quiet challenge of that seated figure, not just to interpret it, but to sit with the discomfort of not knowing. Buried beneath the dry earth of the Indus Valley, secrets still wait, not just in the ground, but in the very air above it. Modern archaeologists aren't just digging with shovels anymore, they're wielding lasers, LiDAR technology, the same airborne scanning that peeled back the jungle to reveal lost Mayan cities, is now sweeping across the plains of Pakistan and India, revealing ghostly outlines of settlements no one knew existed. These aren't just small villages. Recent surveys have detected massive, low mounds stretching for miles, entire cities swallowed by silt, their grid patterns faint but unmistakable beneath the soil. One newly discovered site near the dried-up Gagha-Hakra River shows something extraordinary, a circular citadel with radial streets, a design unlike anything previously associated with the Indus people. What other urban experiments might lie hidden, waiting to rewrite our understanding of their civilization? But the real breakthroughs aren't just about finding more ruins, they're about decoding what we've already uncovered. Take those thousands of undeciphered seals. For decades, scholars struggled to match their symbols to any known language. Now, artificial intelligence is attempting what human minds couldn't. Machine learning algorithms have identified recurring sign sequences that may represent grammatical rules, while 3D imaging has exposed microscopic chisel marks suggesting the script was meant to be read tactilely like Braille. One controversial theory even proposes the symbols aren't words at all, but a lost musical notation, their curves and lines corresponding to pitches and rhythms. If true, those silent seals might hold the melodies of a civilization we've only ever seen, never heard. Meanwhile, in labs around the world, scientists are dissecting Indus artifacts at the molecular level. Neutron activation analysis of pottery shards has traced clay sources to specific riverbeds, revealing trade routes stretching deeper into Central Asia than previously imagined. DNA extracted from human teeth at Rakhigarhi challenges old assumptions about the civilization's genetic makeup, showing connections to ancient Iranian farmers and South Asian hunter-gatherers. Even something as simple as mud brick is yielding surprises. Spectrographs reveal some bricks were intentionally mixed with plant ash, creating a self-repairing material where alkaline salts slowly crystallize to fill cracks, an ancient precursor to modern, living concrete. The most tantalizing searches aren't confined to the past. Some researchers are actively reviving lost techniques. In a small workshop near Jaipur, a team of metallurgists and traditional craftsmen have spent years trying to recreate the iconic dancing girl bronze using only tools and methods available to Indus artisans. Their experiments reveal how challenging it was. Achieving that flawless copper-tin ratio required not just skill, but an almost intuitive understanding of furnace thermodynamics, with artisans judging temperatures by the color of flames and the sound of bubbling metal. Yet their closest replica still lacks the original's eerie lifelike quality, proof that some secrets remain locked in the hands of those long-gone masters. What drives this relentless search? It's more than academic curiosity. The Indus Valley Civilization represents a road not taken in human history, a society that thrived without pyramids or ziggurats, that prioritized sewage systems over statues, and that may have valued collective well-being over individual glorification. In a world grappling with climate change and social fragmentation, their example feels urgent. How did they maintain that remarkable standardization across hundreds of miles without centralized coercion? How did they engineer climate-resilient cities in an era without fossil fuels? Every new discovery peels back another layer, not just of their world, but of possibilities for our own. The past isn't finished speaking, and with every scan, every algorithm, every painstaking experiment, we're learning to listen. From the labyrinthine sewers beneath Mohenjo-daro to the celestial mathematics etched into Dolivera's stones, the Indus Valley Civilization wasn't just ahead of its time, it was playing an entirely different game. Think about it, a society that standardized brick sizes across an empire while others struggled with uneven mud walls. A culture that engineered tidal docks when most settlements still dragged boats ashore. They spun cotton into fabrics finer than modern linen, mixed mortars that outlasted millennia, and possibly even harnessed the stars to guide their cities' layouts, all without leaving behind a single decipherable instruction manual. These weren't just inventions, they were revolutions disguised as everyday objects, each one whispering secrets about a world where urban planning, metallurgy, and trade reached heights the ancient world wouldn't see again for centuries. Consider the paradox of their legacy. The dancing girl's bronze still gleams with untarnished perfection, yet we've lost the alloy recipe that made it possible. Their sewer systems still channel water after 4,000 years, but the engineering principles behind them vanished with their builders. Even their iconic unicorn seals, mass-produced yet meticulously detailed, represent a system of commerce and communication we can't fully reconstruct. This civilization challenges our assumptions about progress itself. How could technology so advanced appear fully formed, then disappear without a trace? Why didn't neighboring cultures adopt innovations like standardized weights or climate-responsive architecture? The answer might lie in their very uniqueness, a society so interconnected, so dependent on collective knowledge that its brilliance couldn't survive fragmentation. What's perhaps most humbling is realizing how much we still don't know. Those undeciphered symbols on their seals could hold anything from epic poetry to grocery lists. The ghostly impressions of their textiles hint at dyes whose formulas we've yet to crack. Even their failures fascinate, like the mysterious abandonment of cities that show no signs of war or catastrophe, just a slow unraveling of social fabric. In many ways, the Indus Valley's true lost technology wasn't any single invention, but the invisible web of trust, coordination, and shared purpose that made such innovations possible. Now it's your turn to dig deeper. Which of these ancient marvels sparks your curiosity? Is it the hydraulic genius of the Great Bath, the cryptographic puzzle of their script, or something subtler, like the terracotta figurines that blur the line between toy and talisman? Drop your thoughts in the comments below, and if you're hungry for more mysteries, hit that subscribe button. This isn't just history, it's a conversation across millennia, and we've only just begun to listen.